This is a part 2 of a video which is related to the arches at a different level. Okay, up to here I solved. I will continue with this. If you have any doubt, please refer the previous video, which will be in continuation with the previous video. Okay, so they are asking the question, you have to find out normal thrust and radial shear bending moment at 15 meter from the from point A. So this is the question what we followed. I considered ear to ear portion. So ear to ear distance I considered as 15 meter. So the portion, it will looks like this. So we know UDL of magnitude 40 kilonewton per meter, and this is the horizontal load, you know, vertical load, you know. You have to calculate what is VD in order to find out bending moment. Before that, you have to calculate normal thrust and radial shear. So in order to calculate normal thrust, unknowns are H, you know value, theta you have to find out, vertical load we have to calculate. H, you know the value, okay, that it is as follows. In order to calculate theta and V, okay, we know this is a portion, it is in between A to C, okay. So the portion is in between A to C, then you have to consider the equation of rise as portion A to C, okay. Then from that equation of rise we get this slope equation. It is as follows. In the slope equation, we have to substitute x value as 15 meter. Then you can easily find out the direction, or we can say theta value, that is 25.97 degrees. Okay. In order to calculate V, that is vertical shear, what and all vertical loads we have, that should be considered. Force moving upwards, VA positive, and we have UDL 20 and here for 40, and here to your distance it will be 15 meter. Okay, it is acting downwards, so it will be negative. Okay, then you know H value, you know theta value, and you know V value. Then you can easily calculate the normal thrust and radial shear. Okay, before that, you even in order to calculate YE value, why I am considering rise equation as rise equation as well as slope equation for portion A to C, because this is in the portion, within the portion A to C. That's the reason. Okay, yeah, see here now I am considering equation of rise for the portion A to C as follows, and put x is equal to 15 meter. Then you came to know what is the YE value. Okay, that YE value will be 12.75 meters. I am considering that one as YE. So in order to calculate bending moment also at point E, so you have UDL, horizontal force, force moving upwards positive, horizontal negative, vertical force acting downwards, negative bending moment. Okay, yeah, and before that we have to calculate normal thrust as well as radial shear. So it will be as follows. So normal thrust formula is this one, radial shear formula is this one. H value you know, theta value you know, V value, substitute this one, you will get normal thrust as well as radial shear. And in order to calculate bending moment at that point, you know YE value, it is 12.705 meter, and we know ear to ear distance is 15 meter, and this is the UDL what we, this is the previous figure only I considered to explain you about the problem. Okay, bending moment at E, UDL, see this is the force moving upwards, and ear to ear perpendicular distance is 15, and UDL acting downwards, negative bending moment minus 40 into 15, and ear to ear perpendicular distance is 15 by 2, and we know horizontal force 38.15 multiplied by, we know YE value, it is 380.14 multiplied by 12.705. that will be the vertical distance YE, that is the perpendicular distance for this horizontal force. Then you will get the bending moment at point E. Okay, after finding bending moment at point E, then once again they'd ask you to find out the maximum bending moment. As I told earlier in the previous problem also, maximum bending moment we will get at the point where the point load is acting, or if it is a UDL acting throughout the span, the maximum bending moment will be at the exactly at the center. Okay, that's what I consider. First I am considering portion A to C. For portion A to C, maximum bending moment will be, yes, here this is the portion A to C. For this portion, somewhere maximum bending moment will be half of this one, because UDL is totally it is acting, so maximum will be exactly at the center for the UDL. So center distance will be L1 divided by 2. Okay, that one is as follows. L1 divided by 2, it will be 12.425, and we know it is a UDL, and we know H value, we know VA value. We can easily calculate the maximum bending moment. Here unknown is Yx. For that, this is falls under portion A to C. That's the reason we are considering rise equation as this one, and I am substituting x value as 12.425. It is half of L1. Okay, then you came to know Yx value is 11.291 meter. Okay, approximately I am considering. Then I am finding bending moment. I am considering that point as x. Okay, and I am considering the point, this one, as x. So I am finding bending moment with respect to x. So it is as follows. So bending moment at point x as follows: vertical load multiplied by 12.425 because positive moving upwards, minus 20 into, this is a vertical load acting downwards, so that's why 40 into 12.425 multiplied by 12.425 by 2, and horizontal load, its vertical distance as Yx, and we know Yx value. Substitute that one, you will get the maximum bending moment at this point, maximum bending moment at that point. So it will be 1646.17. Then we have to calculate maximum bending moment with respect to the portion B to C. So portion B to C, it will be looks like this. Maximum bending moment will be at the point where the point load is acting, that is point D. So we have to consider only this portion. So that will be as follows. Okay, and we know this is for portion B to C. So Y value, that is equation of rise, we have to consider for portion B to C, that will be 1.701x minus 0.024 x square, where we know x value as 10 meters. Substitute that one, you easily get ear to ear distance as YD value, that is 14.67 meters. Okay, you know YD value how to calculate, means substitute x value as 10 meter in Y equation, and this Y equation, rise equation, is we have to consider this rise equation such that it should be for the portion B to C. Okay, because of different level. Then bending moment at point D, it is the same procedure what we followed for the previous one. Then you will get the value as minus 901.25 kilonewton meter, where negative sign indicate it is a maximum negative bending moment what we got. Then the bending moment diagram is as follows. We know at point A 0, at point C 0, at point B 0. Okay, that I not told in the previously. Okay, bending moment at A and C and B are 0 because there's 3 points we have hinges, and we know at point X it is 1646.17, and at point E it is 1567.22. okay, and we know here we have UDL, so you will get a curve. Okay, and here we have a point load and its magnitude is 901.25 and it is negative, so it is below the center line of the arch. So it will be as follows, and this one, it is a point load, so I drawn an inclined straight line. This is positive, so I written above the arch. Okay, this is the bending moment diagram. There ends your problem, and this is a similar procedure will remains the same, but there is a bit difference in the approach. That's it. Procedure will remains the same. Okay, thank you. And most of the problems related to arches are solved. Okay, all the different varieties of arches problems we solved. In the next class we will see about cables. Thank you.